Okay, x can be a whole number, a fraction, or a decimal, okay? Now, for our geometric sequences, it's the same. We saw those last week. We've been working with them for a while. F of n equals the initial value times the multiplier raised to the n. And what did I say is your new exponential function? What is our geometric going to be called? It's y equals what? You used it yesterday and in your warm-up today. A times what? B to the x power, where a is the initial value like I and b is the multiplier like m, okay? There is a question very similar to this tonight. Okay, if we look at our next one, here's some more information. We've already copied this down. What did I say a is? So we have y equals a times b to the x. What is a? Good, our initial value, our term 0 or our y-intercept. And what was b again? What do we call it, really? The multiplier, good. Okay, the multiplier, the common ratio, or the rate. Okay, and you guys like to call it the big slope. So I'm going to get ready to move on, but before we do, we talked about there are two types of exponential functions. What was the name of the one we used yesterday, and what was the one I've been talking about mostly today? Exponential what? Exponential growth, which means I'm getting bigger. What's the opposite of growth? Decay. Okay, that's what we call it here. So I'm going to have you sketch a model of both of those. So our two types of functions, exponential growth, and that's when b is greater than 1. Our multiplier is larger than 1. And our decay model is where our multiplier is between 0 and 1, okay? So a fraction that's less than 1. Because remember, we can have fractions greater than 1, okay? But this is going to be a fraction or a decimal that's less than 1. Okay, now these next two, you're going to have to graph them. So please graph neatly in your notebooks. I forgot to give you graphing paper, and it's going to take a while to pass it out. So fortunately, the numbers are not too gigantic. Just be neat, please. So our first function is g of x equals 2 times 3 to the x power. So we always want to start by making a table. And I always like to start with 0 for exponential. And you're going to substitute the x value into the equation and then solve for x. Okay, so I'll let you write down that table real quick and your function. You don't have to write the graph down quite yet. We'll write it when we're graphing. Okay. So if I'm substituting my x value into my function, what is my first x value going to be? My first x value. My first x value. I'm going to substitute 0 in. I know what you're thinking, Sam, but I'm not there yet. Okay, there's two ways we're going to do it. One, the first way, and then I'll show you the second. So I have 2 times, what is 3 to the 0 power? 1. And what is 2 times 1?
2.
So that means that this is my first point. Does that make sense?
Yeah.
Okay. What's the next x value I'm going to substitute in? 1. Good. So I have 2 times what?
3.
3. And what is 2 times 3?
6.
Perfect. Does that make sense so far?
Yeah.
Okay. Now my next x value is 2. So I have 2 times what? 9. Good. Which is? 18. And then I'm going to do one more. 2 times 3 to the what power? To the 3rd power, which equals 2 times 27, which is, I'm going to tell you it's 54. Can you use a calculator on this? Yes, we won't really need it today, so that's fine. Okay, so I can plot each of these points. I'm going to plot 0, comma what? 0, comma 2, 1, comma 1, comma 6, and 2, comma 18. Do I have to put 354 on there? No. Bless you. Sometimes you'll be able to fit it, sometimes you won't. So I'm going to graph this. Does that look like an exponential model? Yeah. Okay, now there's a little bit of an easier way to do this. If I say my equation is a times b to the x power, what is my a value? What does a equal? A equals 2. Do you understand that? And what does b equal? B equals 3. Does that make sense? And what did a stand for again? What do we call our a value? Our initial value or our 0 term. So I can write a here. And what did b stand for? My multiplier. So what's 2 times 3? And what's 6 times 3? And what's 18 times 3? Okay, does that make sense? That's another way I can solve this. Did I get the same numbers both times? Okay, so we're going to do one more, and I'm going to do it that way, using my a and b values, okay? This is our last one, and then I'll put up the U-try for you guys to do if you want. Okay? So what is my a value on number 2? What does a equal? 4, good. So I'm going to write that as my 0 term, and what's my b value? Is 1/2. Now, can you tell me, is this going to be growth or decay? How do you know? Because it's less than 1, okay? So b is my multiplier. What's 4 times 1/2? 2. That is 4 divided by 2. What is 2 times 1/2? What's 2 times 1/2? 1. What's 1 times 1/2? 0.5. And what's 1/2 times 1/2? 0.25. Does that make sense? Okay. I know I'm going through it a little bit quickly, but I think you guys will be okay with this. If I can graph these points now, I'm going to graph 0, 4. Then what? What's my next point? 1, 2. Then what? 2, 1. Then what? 3 and 0.5 and 4 and 1/4. So if I graph this, is that a decay function? Okay, does that make sense? Okay, we will practice this some more tomorrow. Let me put up the U-tries if you'd like to take a picture so you can do them for a bonus scale. Okay, here are the U-tries.